Session. There we are, guys. We're starting with the session. If you can log in first in Slido, that's the barcode. This is the link, but the easiest way to do it is to type slido.com and then type this reference here. If you don't know how to do it, I'll show you. So I'm just going to go to a browser, and I'm opening Brave now. But Brave always keeps doing updates, and so hopefully it's not going to do an update now. You just type Slido, and then you enter the code here. That is the easiest way to log in if you cannot scan the barcode. But if you can scan the barcode, that might be your preferred choice. The code for this slide is 5579980. So we are starting with that. Just pick a chair. Okay, so on Slido, what I expect you to do is to ask there's the open questions, ask a question, because I really need to know. If you're camera shy, please don't sit on that chair because it's recorded, if you're camera shy. It's recorded for you guys, so but it's going to go live on YouTube. Now, on Slido, there's open questions. Please start with asking some questions. Just to show you why that is important, I teach this course with many organizations. So as you can see here, I'm teaching in March for 4 days, exactly the same course, for 4 full days, 8 hours. Whatever questions you have, probably I have material for you. Whatever demonstrations you want, probably I have a demo to show you. But that needs to come from you. Otherwise, I do have PowerPoint slides of what I think is the most important, and I'm going to cover those topics. Now, but I do need your input if you want a specific aspect about Agentic AI. Agentic AI was in 2025 was the most discussed topic in terms of AI. We expected to have AI agents, but we didn't. So it just ended up being the most discussed topic. But in 2026, it will change. By the end of this year, especially in the Department of Law and Admin, many admin jobs will disappear. So by the end of this session, you will know why. If a task is, hold on, let me take this. But by the way, as you can see, I'm teaching this same course for 4 days. Whatever questions you have for me, probably I have an answer for you, and I have a demonstration. I have used all the Agentic AI tools, and I have demo prepared for each one specifically. But it needs to come from you. In Slido, if I open Slido here, you have this open, and there's 0 questions over there at this present moment, which means that you don't really have any questions. As we progress with the slides, I will use Open Cloud. I will try to prompt and get input out of you, but it's difficult for me to know what you individually want to know about Agentic AI. What we're gonna cover, I'm moving on from Slido. You have the code, everybody. So this is the code 5579980. You need to scan the barcode as well. So for the people who joined a little bit later, please log into that. It's the way that we're gonna interact in this session. Now, I think one more person is. Did it work? Can somebody write it down? I think somebody is writing it down. Can you write it down on a piece of paper, this code? Because I'm going to move away from this slide. I have to start the session. You have? Okay, so if somebody asks you for a slide, just give them this code, 5579980. As we learned from the last session, if I go into full presentation mode, because that's a Windows screen, basically it's going to blank out everything that I show you in terms of demos. So that's why I'm going to use this screen. If you prefer, I can go into the maximum screen, which is this. But then when I open Windows on Google, when I open VS Code, when I open different things, you don't see them on this screen. So I have to remember to log out. That's why I think it's easier if I just use this screen, because then I don't have to do that, and I can maximize this a little bit. Maybe I can even remove this section here. Yes, so that is gone. I'm gonna minimize the nodes, and this is almost as good as that. Anybody knows what is the main security risk and security concern from Agentic AI specifically, which is different from AI? Anybody knows what is the difference? I'm going to be asking you prompting questions, and if you know the answers, please speak out. This is how I'm testing your level of knowledge, so I can balance the class. There's no point me jumping into the most advanced forms of Agentic AI architecture if you don't know the difference between AI agents and Agentic AI. Now, that's a good question. Do you know the difference? Can somebody explain the difference between AI agents and Agentic AI? No? How about you, sir? No. AI agent, I will demonstrate AI agent is a single agent. So ChatGPT 5, for example, has AI agent that you can build internally. Claude would have the capability to allow you to build one agent, one AI agent. ChatGPT 5 is a PhD level of coding and development of AI agents. So you can basically create your own AI agent that will code to the level of a PhD, and I will demonstrate how those capabilities are developing and evolving over time. And that will hopefully change your narrative of what careers are going to be safe in the future and what career paths are already obsolete, even though maybe you're not aware of that. So AI agent, one singular AI agent. Agentic AI is an orchestration. This is when you orchestrate maybe 1,000 AI agents, and you are basically acting as the manager. So you're managing this orchestration, and one AI agent could be coding, second AI agent could be marketing and development, basically pushing your product on the market. Third agent could be a compliance agent, checking if your Agentic AI is transparent. Fourth AI agent could be very specific, built to design AI bombs. We're gonna talk about AI bombs tomorrow. That's very much from regulatory and legal perspective. AI bill of materials, software bill of materials, cryptographic bill of materials. Those are US efforts, AI bomb, S bomb, C bomb. That's in tomorrow class. So you could have technically one AI agent running each one of those. One could be building AI bills of materials, second could be building software bills of materials, third could be building cryptographic bills of materials. From a legal perspective, why do you think this is problematic? It's an easy question. You know now. By now you would know why this could be problematic, because we had the first session on foundational AI, then we spoke about quantum computers, we spoke about blockchain. Why is it problematic to have AI checking itself? No? Hallucinations. It hallucinates. We have designed generative AI to be interactive, to be fun. That means if it doesn't know the answer, it will generate the answer. That's what it stands for, generative AI. It generates. So it will generate something for you. Now, not yesterday, the day before yesterday, I showed you the video demo, which nobody has asked me on LinkedIn, but I do have that link to show you, to send you, when a reporter asked generative AI to write a summary of his podcast, and it created a summary of his podcast before anybody has actually seen the podcast. So generative AI didn't have access to his podcast, but it created, and then started arguing with the reporter. He started saying, no, you showed me the podcast. It shows you the date, shows you the time. At that time, in that day, you showed me the podcast. I have the complete podcast in my memory. So this is a summary of, and after like half an hour of argument, generative AI says, no, I lied. I just wanted to make the interaction more fun. So that is why you cannot use AI to check itself. When artificial intelligence is generating those AI bills of materials, how do you know that they're correct? How do you know that there's no sleeper agent that is going to get activated at a later stage? You don't. So part of the European Union AI Act, which is coming into force this year, it's the equivalent to the GDPR, but for AI specifically, you will have penalties. If you work for an organization that is using Agentic AI and that AI agent has hallucinated, who is responsible? You, sir. You are responsible. Because it was your job to create the report. It was your job to create the AI bill of materials. Now, you use the Agentic AI, the regulator doesn't care about that. The regulator has very specific instructions. You have to produce transparent AI bill of materials. So your AI needs to be transparent. If your AI is not transparent, then you have the legal responsibility. AI is just a tool. And if you have AI agent versus agentic AI, which is orchestration, except AI agent is one, you can check one. If you have agentic AI, which is 1,000, how can you check 1,000? That creates, actually, if you have bad AI agent, those could be 10x engineers. You know the term 10x engineer. When you're making so many errors that you need 10 people to walk behind you and correct the errors, that's a 10x engineer. So each one of those agents, if it's not designed properly, it's going to be a 10x engineer. It's not going to save you time, it's not going to speed up and automate the process, it's going to create so much work for other humans that people just won't be able to catch up behind it. So how do you build AI agent orchestrations that they are not going to end up being 10x engineers? What is the steps? How do you know if a task is suitable for an AI agent or non-suitable for an AI agent? In terms of the technical capabilities of the current level of artificial intelligence and agentic AI. What task can an AI agent do? What task can an AI agent not do? Now, at the beginning of the session, I said that you're going to be managers. What is a good manager? You show up in your office and you know exactly what I need to take this off. Because Apple Watch keeps telling me things like go for a walk, stand up, you've been sitting too long, so I have to take it off. Where was I? You have to be a good manager. You show up at work and you have 1,000 AI agents. Now, you're no longer developing code anymore. You're no longer writing the reports. You're no longer writing the AI bill of materials. You're managing that orchestration. And what skill does a good manager need to have comparing to a researcher? If you're a researcher and you want to be locked in a small little room with a little window and spend 6 years developing a robotic arm that just needs to do this in order to be sent on Mars, that is your job. You're a researcher, you do only this. But your manager
knows which people to hire.
Which people to hire? Well, AI agents would be your employees. You would be employing AI agents. They have tokens, so they cost money. Yeah?
And how to organize it and how to manage it.
Exactly, you're becoming a manager. So when you show up to your work, you're no longer a lawyer, you're no longer an administrator, you're a manager. And a good manager needs to have clarity of the tasks that you need to perform. Now, as a researcher, I know I can manage my own project, but if I'm managing a group of 20 students, for example, each one has its own project. In my mind, I need to know what each student needs to do. And for me, with my experience, that's a very easy job because I know, let's say you're writing dissertations. What's the key requirement of a good dissertation? Even professors don't get this. Last week I had a discussion with 3 high-level professors, they still don't get this. What makes a good dissertation? How do you write a PhD really easy? You pick a topic. You don't expand into cybersecurity. You don't go into supply chain. That's an area. That's not a topic. That's an area. You cannot cover in one dissertation the entire area. You need to narrow it down. And you need to do the same for the AI agents. So you need to narrow it down specifically. It needs to know what you want it to do. Otherwise, if you say, identify all the risks from supply chain infrastructure, which supply chain infrastructure? Walmart's, Google, mining industry, which region? Eastern Europe, Poland, China? You're not being specific. And this is not good for your dissertation. This is not good for agentic AI. But if you narrow it down more specifically to say, what are the supply chain risks for data poisoning from now you need to pick. Now, I don't want to give you an example because if you work in a medical healthcare, then it's going to be secure multi-party computation between different hospitals. If you work in a trustworthy environment, what's the data poisoning from differential privacy, for example? What is the risk for data being poisoned even after applying differential privacy? Those are techniques. Differential privacy means you take a data, the meaning, let's say you're all this group, the opinion of this group is that AI can cure cancer. Now, if I add differential privacy, I will keep the meaning, but I will add the noise. The group size will become 10,000 or 5, and that makes it difficult to identify who said what. That's differential privacy. And secure multi-party computation is a different technique, how each hospital would process the information and only share specific aspect of that information to the algorithm. And that makes it possible for a hospital in Texas to share patients' data with a hospital in Warsaw. Otherwise, it's not possible because of the regulations, patients' data, privacy, yada, yada, yada. So if you're that specific and you wake up in the morning and say, okay, this AI agent is the same like my PhD student. He needs to identify this specific task. And this is when AI agents become helpful. What is the use case for using AI to generate a report on what's the supply chain risk? You can use Google for the same thing. You Google what's the supply chain risk, it will produce tons and tons and tons of reports. But once you make it specific, that's when that AI agent becomes useful. Second thing that you need to do with a PhD student, with a master student, and with an AI agent, you need to define the methodology. Is it qualitative? Is it quantitative? What kind of data are you going to provide the agent? What kind of data are you going to provide the student? Because different methods require different data. If you're talking about case study, that's a qualitative approach. If you talk about action research, when you are based in a company or in an organization and you're investigating the action, then that's a different research method. Then you can combine case study with action research, but they are separate. Or is your methodology grounded theory? Grounded theory was developed by two clinicians in a hospital. How you call those? They're not professors, they're clinicians, I think. And they work with people that they are dying. So grounded theory was developed in a book called Awareness of Dying, because they interviewed the people who were dying and they asked them questions. Does this person know that he's dying? Okay, the doctor will tell you you're going to die in 6 months. But is he aware? Because many people, they found out that many people are not aware. Until the very last moment that you die, you kind of hope that you're not gonna die. And that was the purpose of that book. That's grounded theory. By the way, sir, if you sit there, remember that you can be on the camera, so you don't mind? Okay. So moving away from the qualitative approaches, that could be one AI agent. You cannot have one AI agent running case study, action research, and grounded theory. Those would be 3 agents. Now you see how you're automating your PhD work to Agentic AI. Where are you going to get the data from? Is it going to be qualitative or quantitative? AI agents are not very good with qualitative data, interviewing people. And most PhD students and master students, they think, oh, I'm just going to set up a bunch of interviews and I'm going to interview those people, I'm going to process this data, this is going to be so easy. And then they realize how difficult that is. You need to do sampling, so you need to choose the correct people to be interviewed. You cannot just interview anybody and say, person X said this, so that's why it's correct. So if you're talking about how to make money, you need to interview people like Warren Buffett. He knows how to make money, right? He has proven that he knows how to make money. If you want to interview somebody about building convolutional neural networks, you need to interview the people who build the convolutional neural networks. Now, I have access to some of these people because they're all based in Oxford or MIT or Cambridge, but you might struggle. I might meet them in the corridor when I walk around and have a chat with them. Can I use that in research? No, I can't. So even I don't really have access to these people. So how is AI agent going to get that access? Qualitative data for Agentic AI, it's really difficult unless, I'm going to contradict myself now, unless you're using social media, Grok and X. Now, oh, that's a very loud computer. Do you need it? Grok, why is Grok connected to X? Because it gets all that input, the social. Hold on, just 1 second, guys. Let me check the timing when this course finishes, because I need to. As I said, I can talk about this for a long time, and there's going to be loads of demos and information. But let me check what time do we need to finish.
10:30.
10:30. Behavior responsible. So this is the course tomorrow. 10:30. Yes, exactly. 10:30. So And if you build a different type of AI agent for quantitative, now that's going to make it a lot easier. Most people who work in law, admin, social scientists, they're really scared from quantitative approaches. In terms of agentic AI, that is really easy. Let me show you. And you can repeat these steps. Hugging face. Now, how do you find data instead of going interviewing people and wasting time, and they don't want to meet you, and they're going to say, I'll meet you in March 25th because my schedule is busy on March 25th, and last minute they cancel, and then you don't have anybody to interview, and you have panic attack, and your PhD is going into disarray. You could use Hugging Face and look at some of those data sets here. So data sets and models. You have models and data sets. Has anybody clicked on Hugging Face? Did I click that for you in the last few days? Do you remember? Can you tell me how many data sets do you expect to see here? Once I click here, how many data sets do you expect to see? 50. 779. So there is a lot of data that you could analyze. Imagine that you build an agentic AI, then you want to use those data sets. They exist, you can download them. You can actually connect AI agents with LangChain directly to those data sets. Now, how do you know which one is relevant for you? Going back to the beginning, you have to be specific. Your topic needs to be specific. Then you need to have specific methodology that you're going to use. And the methodology will also be based on the models. Now, if I click here on models, those are AI models, pre-built AI models. You don't have to build them, plug and play. You can use VS Code, you can download those models and start using them. You can use Codex with Agentic AI, download that model, start using them. How many models do you expect to see over there? Those are AI models, specific AI models for free. You don't have to pay anything to use those models. Just give me a number. I know you don't know the results. 100,000, okay. Let's see. Actually, that number changes all the time. 2.5 million. You have 2.5 million AI models for free designed in an online repository. There's multiple online repositories. This is only one. This is not the only repository. PyTorch on Python. If you're coding in Python, PyTorch is a repository. So you can recode those models without actually bothering with Hugging Face. PyTorch contains a library of models and library of datasets that are built in Python. TensorFlow has a separate library. Most organizations, companies that you might work for, they have proprietary models. They might prefer that you use that proprietary model. Google has Gemini 3, OpenAI has the ChatGPT 5, Cisco has their own models. Why do people build, why are organizations building models? Probably you're not going to know the fullness of this answer because it's not only one answer. Organizations like Google and OpenAI are building those models because they want to commercialize them. A Microsoft Copilot is a commercial product. You want to use Microsoft Office 365, you use Microsoft Office. Is it useful for the type of work that I do? Microsoft Copilot is useless, completely useless. But GitHub Copilot is extremely useful. Now, I did mention GitHub Copilot to all of you. How many of you have managed to log in, register, and get the free 2-year subscription for GitHub Copilot? Nobody. Now, that's a good point. So I will have to demonstrate how, guys, you need to do that because otherwise you're not going to do it. Part of this course is Agentic AI, which is what we're teaching today. I will demonstrate VS Code with Agentic AI. If you did that, it takes 72 hours. Now you would have been able to test it. But because you had other things, you didn't find time. So let me demonstrate how you do it. I can sit down for this because I work faster when I'm sitting down.
Sorry, sir,
yeah?
can you open the window, please?
The window?
The window.
That window, okay. I don't mind the cold. As you can see, I'm on short sleeves. But some people don't like the cold. So I will keep it open for 5 minutes and then I'll shut it down. Actually, I prefer open window because of the clean air. Yeah.
These data sets are real or AI generated?
These data sets are what?
You show 79,000 data sets. Yes.
Yes.
These data sets.
Yes.
These are real.
Sorry?
Real data sets?
Real data sets. Yes, of course, real data sets on various different topics.
But how
So
they are
when I-
verified?
Sorry?
How they are verified that they are real?
How they're verified that they're real? Hugging Face does some form of checks and verifications. We're expanding into more scores on the AI bill of material. You will be able to automate the process for verifying data in the future. We already have links. It's as simple as copying and pasting into a tool that is going to show you the data provenance. Where is the data coming from? Are they completely secure? As this course will expand, you realize that in Agentic AI we don't actually have regulations yet. There's no regulations, there's no process for checking Agentic AI. There are many people working on this topic now, but what you're asking for, it's not possible with our current capabilities. If you want to test a black box model, you can extract the weights, you can reproduce what it does, but you're not going to learn how it does what it does. Now, I know this is kind of like really not good for you guys, but imagine that you work in a hospital and you're trying to develop a vaccine for a new virus. How do you do it? You have rats, you have laboratory rats, there's lots of rat A, rat B, rat C, and then you give them the virus, different types of viruses, and then you give them a different types of solutions. You don't know how that solution is going to react. That's why you don't give it to human. So what you are expecting that you know what AI does and how it does it, it's not realistic. That's the starting point. And from the beginning I said many people are working in areas that they say data privacy, yada yada yada. What you're asking for is not realistic. I was going to say something else, but let me answer that question because, as I said, you navigate the interaction. I have demos for everything. So whatever you ask me, I shift it in that direction. But let me find the demonstration for what you specifically asked me for. Just one second. I will find it. Oh, the bitter lesson. I really need to talk about the bitter lesson. Bitter lesson is somebody who worked with AI for all his life, and at retirement he wrote the bitter lesson. That's the bitter truth that he learned at retirement about AI. Crime in the world. AI bubble. Just one second. I will find it. I will show you. Concept reasoning. Okay. AI laws. So you know, actually, my folder is called AI laws. So it's a really good question. That's why I'm opening this, because you asked a question that is relevant to lawyers, and this is a department of law, right? Now, this year we have AI, EU AI Act. This is the European Union AI Act, which, let's open the European Parliament. AI Act. No, this is European Parliament webpage, but it's not the official webpage. Okay, this is the official webpage for the European Union AI Act. The European Union AI Act is every country wants to be good at something. Every country wants to lead in something. India wants to lead in this. US wants to lead in that. European Union wants to lead in this. European Union wants to lead in AI regulation. European Union is leading in AI regulations. So this is the most advanced regulation on artificial intelligence. I do criticize a lot the things that are happening in the European Union, and I did actually download some videos from the British Parliament, how they argue with each other, because it's important that you criticize regulation. That does not mean that I don't support them. Actually, every time I need to resort to some kind of argument with an employer or somebody, I always use the GDPR. And recently, for example, I've noticed that Oxford keeps my job applications from 10 years ago. And I was like, according to the GDPR, you need to keep them for 12 months, not longer. Please delete them. For 2 years, they're not deleting them. They said, oh yes, we'll delete them. And I was like, I have to send them another email. Why haven't you deleted? Oh yes, we'll delete them in 28 days. 28 days later, I send them an email. Why you haven't deleted them? And they are just not used to deleting data. They want to keep everything. Why? Now, I checked Cambridge because I worked in Cambridge before. I checked their job portal and they keep, you know, like job portal, you find your previous job applications. I checked that and I sent them an email. Hey, why do you keep my job applications from 15, 20 years ago? That data is old. Oh, they were like, oh, we forgot, we'll delete them. They're not deleting them. They still exist. If I log in now to my Cambridge and Oxford, they keep my job applications from 15 years ago. I have no other way to fight these people. You cannot fight them, except mentioning the word GDPR. So when I mention the word GDPR, at least I get a positive email saying, we'll delete them in 28 days, we apologize because they have to pay a penalty if they don't comply. They're still not deleting it. So when I criticize European Union regulation, doesn't mean that I don't use them. I just think that sometimes they are designed in a way that represents narrow-minded people. Now, let's talk about Oxford before I go into this. In Oxford, we have computer scientists that they believe that computer science should not be worked on computer, pen and paper. They only believe in pen and paper. We have a group of very prestigious professors in Oxford. They're just the quarter next. I'm not allowed to speak about this in that quarter because they're going to get very upset. How can you write machine learning with pen and paper statistics? Yes, I mean, technically you can, but it's not going to be very useful. So we have those people. We have a group of people that they really don't want to use generative AI for anything. When ChatGPT came in 2023, I immediately started with my own subscription. I said, are you going to pay? I need to test this. They said, no, you're not supposed to use that. That's like the devil himself. 2 years later, now my subscription is paid by University of Oxford because a different voice predominated over those voices. There's always voices in every institution. Now, luckily, we had lots of reasonable people in Oxford who actually convinced the vice chancellors, the deans, and they paid subscription for every student, for every member of staff. My single sign-on, when I log with the same username and password that I log into Oxford, I can log into ChatGPT. That's what happened in Oxford now, 3 years later. With the European Union Act, now let's start criticizing it, and I hope I made it clear that I'm not against it. I'm just saying some narrow-minded voices predominate. It's a really good regulation, but AI models don't comply with this act. None of the AI models can comply with this act. So what's going to happen this year? Those organizations like OpenAI, Grok, how can they show compliance with this AI Act? And Stanford did a study as 2 weeks. This is the table, the summary of this from Stanford. 2 weeks after the European Union announced the AI Act, they produced this table. None of the algorithms is compliant with the European Union AI Act. They're simply not compliant. They say, where did you get your data? They don't know. I mean, engineer who works for a company A, then Facebook, Meta, then 2 years later shifts to Google, then creates a different algorithm, then shifts here and there. There's no method to trace what they did, how they did. Do you really need that computer, sir?
I'll just turn it off.
Okay, because it's going to go on the video, and that's going to be like a noise on the video. So this is the table. OpenAI, not compliant. Google, not compliant. Anthropic, not compliant. Meta, non-compliant. This is done from Stanford University. And that is my criticism about creating this kind of laws. Like the gentleman here said, how do we know that this data is valid? How did we check that data? This also in economics and in other sector, what we call infant industry. Infant industry is when something is so young that you subsidize it and you deregulate it in order for that to grow. AI generative models are infant industry. This has been in existence. The very first model, attention all we need, came in 2016-17, and it was not very useful. The very first ChatGPT model was in 2023. What's going to happen to the European Union after this law now, which comes into force this year? China doesn't have this law. China and US are the two countries that are developing the most AI models. What's going to happen to AI and agentic AI when this comes into force? Is European Union going to prosper and be a leader in the world? No. This will kill every development for artificial intelligence in the European Union. None of the algorithms is developed currently in the European Union. These algorithms, OpenAI US, Anthropic, Claude US, sounds French, it's a US company. Google US, Meta US. Most of that research and development is in California, in San Francisco, Silicon Valley. And it's gonna stay there. Because if they come here, you're gonna hit them with penalties. They don't know how they're gonna break this. When you go to Hugging Face, where is Hugging Face now? When you go and look at this 700,000 data set, if I'm building a model, if I want to build agentic AI, if I want to build 1,000 AI agents, I can do that by the end of the week. I can do it at speed because I have the data, I have the models. I can plug in the model. Actually, in a good day, I might use more than 100 models. And now with agentic AI, the speed of my writing code is what I used to do in 6 months, I do that in 1 day. That's how much faster I am. Now, do you think a human can go and check everything that I have done? If it used to take me 6 months as a human just to manually type that code, do you think another human can go and check that? There's no technical chances that somebody can check what I do. It's not possible. But when you design AI Act, when you design things like this, and you don't include computer scientists, when you include philosophers and legal people who say, hey, we need to be able to check this, when you include those people and you don't include computer scientists, these lawyers, they don't understand that humanly it's not possible to do all the checks. You need to have automation, but that will come as part of the course, which is tomorrow. So today is the course on agentic AI, and tomorrow we're going to be talking about responsible and secure AI deployment, S-bombs, AI bombs. Those, as I said, those S-bombs, AI bombs, they're not European Union efforts. They're US-led efforts. I don't want to drag into that because there's a lot to say about agentic AI. We're going to talk about that tomorrow. So tomorrow we're going to talk about how to make these technologies responsible, how to audit them, how to check them, how to make them transparent. That's not part of the European Union AI Act. The European Union AI Act simply tells you you have to be compliant with this. If you're not, boom, penalty. Now, you go and figure how you're going to be compliant. If you use AI bill of material, are you going to be compliant? Most likely you're going to be partially compliant. But that takes time. Compliance takes time. Let's not criticize other institutions, let's criticize Oxford. I work for Oxford. It's not ISO compliant. ISO has cybersecurity standards called 27001. Every institution that I know is compliant with ISO. Oxford is not compliant with ISO. So if there's a hack tomorrow on the University of Oxford databases, they steal the student data records, yada yada yada, how can we legally defend ourselves in a court of law to say that we have taken all the necessary precautions when we are not compliant with the most established ISO standards? Not to mention MITRE, not to mention NIST, not to mention all those advanced forms of cybersecurity, the very basic ISO, we're not compliant. None of the universities in the United Kingdom that I know of is ISO compliant. Now you need to check if this institution or if your home institution is ISO compliant. There's a very big chances that your institution is not going to be ISO compliant. Why? Because it requires that you recruit somebody who knows how to make things ISO compliant. And then they will start making phone calls. They're not just going to sit in their desk and check the computer, scan the network, which I can, but that's not what ISO requires. ISO requires that you start calling each department and start checking what kind of security infrastructure they have for DDoS attack, for example, distributed denial of service, what kind of infrastructure they have for polymorphic malware, what kind of infrastructure they have for this. They don't know the answer. I mean, just go around this department and ask the dean, what is your tool for DDoS attack? He doesn't know. So that ISO person needs to make a loads of phone calls. He's gonna make your life hell. And once you create, it's a simple Excel sheet. Once you tick all the boxes, next year it's very easy. Next year, because everybody's gonna know the answers and everybody's gonna know what kind of steps they need to do. Everybody's gonna know who to call. But now, when you recruit somebody, he doesn't know who to call. You don't know who to call. Now, how can you do that for AI when if you look at the neural net, neural network. Let me see if I can find neural network architecture. Let me see if I can find a good image. Okay. It's a very, very simple, I know it looks difficult, but it's a very simple form of neural network. This is one of the deep learning techniques. So, in machine learning, you have many algorithms. Neural network is one of the machine learning algorithms. What is that? That is a neuron. The circle is a neuron, and this connection sometimes is described as the weight of a model, the line, the thickness of the line. And when I teach neural networks to people that they don't need to understand every single detail, I say there's a ping pong player here, there's a ping pong player over there. It needs to hit the ball, and this is a table. It needs to hit the ball, the ping pong, the ball needs to reach the other end. If it doesn't get the response, that's a failure. So you repeat the same thing again. So you hit ping pong player here, hits this table, goes to that table, the ball goes out. That's a failed attempt. If you don't get the response, it's a failure. So it's like ping pong, that you have to, but it's not one table, each one of these lines is a separate set of tables. And when you're teaching a machine, that's what you need to do. At the end, you get the result, but you don't really see what is happening because this is a very simple representation. When you look at how many neural nets, how many of those circles, and how many lines they actually exist in a deep neural network, it's far beyond what a human can see. And if you're training it, you feed data, images of cats, images of dogs. Those are not stored here. So you cannot check if this here is the image of that specific cat. You cannot find it. You're only getting the positive response if it's a cat or a dog. So how do you make this transparent? How do you, once you have developed it, once you have all these models here, we're there. Once you have 2.5 million models, how do you check each one? You can't check them. How do you go and check 700,000 datasets? You can't. You have some automation, but there's always going to be a sleeper agent. Sleeper agent is a topic that we need to get to. Let's see, what time is it? So sleeper agents, it's a concept when you build a specific function within a model, but it's not executing it. It's only going to execute that function when you give specific command. So you might build a really good model for the network grid in the European Union to maintain the network supply. Then the model advances, connects to the traffic light system, manages the traffic systems. Then that connects to all the national critical infrastructure. Once it's connected, the adversary would activate the sleeper agent. Until that point, that sleeper agent sleeps. Once it's activated, it will just make a mess of everything. After that might take 15 years. It doesn't cost me anything. It's not costing me money. I'm just plugging in that sleeper agent in all the different models, whichever one you adapt, it's there. And that makes the European Union AI Act extremely important, regardless of all the criticism that I have said. Because when you're building these models at speed, I can build 100 AI agents today, I don't check anything. Nothing, I don't check anything. There's no way for me to check it, there's no mechanisms to do proper checks, and sleeper agents are extremely difficult to check. Even if you run red teaming is like attack and penetration, blue team is defense, and that's how we play. We have a red team line of computer scientists on one side, blue team here. So those guys are attacking the network, these guys are defending the network. And that's how we usually play to make sure that the network is secure. Even if you run that, it's not very useful in sleeper agents, because sleeper agent is activated by a specific command. It's not possible for the red team to find that specific command. The command can be very, very, very unique, and you cannot try every single potential combination for activating the sleeper agent. Therefore, red teaming is not very helpful. Now, just to make sure that we're running on time, that we don't get late, I hope this long explanation, I felt this is the very important thing to cover. The question was on spot. So I hope you understand that we don't really have regulations, and the regulations that we are currently developing, it's not sufficient. Now, going back to the slides here, that's me, that's my background. Agentic AI versus computational AI. We do have some Slidos, so let me check if somebody has asked a question on Slido. Agentic AI. 4 questions. What are the biggest legal risks related to agentic AI? And also, do AI-enabled attack modifier when this type of AI is used by hackers? What are the biggest legal risks related to agentic AI agency? So I'm going to answer these questions, and then I'm going to go quickly with the slides, because the slides contain titles that we need to cover in order for you at the end of this hour or hour and a half, you walk away understanding the problem with agentic AI. What is the biggest legal problem? It's autonomy. Let's say you have a very simple AI agents, booking agents on ChatGPT. You can do that. You can do it now during this conversation. And you connect your credit card to it and say, book me a trip to Sri Lanka. It will find the hotel for you, it will find the flight for you, it will make the booking, it will just ask you to confirm that you're happy with the things, and it will completely automate the process. Now, for that, you need to give clear instructions. Now, we said from the beginning, as the same as a researcher needs to be specific with what methodology, what data. When you're building your AI agent, you need to be specific. And if you say, I want to stay in a hotel that is, yeah, go on.
Sorry to interrupt you. Have you checked the ELI's model regulation on and model rules and regulations on the agentic AI which came like 2025? Which is based on the UNCITRAL model MLAC for agentic. Have you checked on?
For this session, I'm going to use the most advanced regulation that we have so far, that's OWASP. OWASP has created the top 10 risks and the top 10 forms of attacks. There's other institutions that they're trying to build regulation for agentic AI. They're not even near what is required. So, as I said, if you have 1,000 agents and agent 375 malfunction, we don't have transparency that that is the agent that malfunctioned. And if that agent feeds false data to agent 367, 379, hallucinates, and that propagates into the data supply chain, by the end you get a wrong result, but because you have 1,000 agents, you don't know which one malfunctions. So you have to go each one individually, and I just showed you the step why that is so difficult. It's very easy to create a regulation and to say you have to check everything. It's not humanly possible to check that. It's not about creating a regulation, it's about creating a technique that is going to enable you to check that. If I can build now 6 months worth of code in a single day, you cannot hire somebody to work behind me and check that for 6 months. It's not possible. You need to have AI checking that. Snoop, for example, checks the code for vulnerabilities. Now I can demonstrate that tool. It's going to check the infrastructure as a code, and it will provide a very certain level of vulnerability detection based on the National Vulnerability Database, which is more than 300,000 vulnerabilities. So if you have 300,000 vulnerabilities in a database, and you need to check my 6 months worth of work against each one of those, good luck to you, sir. You're not going to make it. It's not possible. But a philosopher does not understand that until you actually explain it to them. Once you explain it to them, you know what they say? We shouldn't be using AI at all. That is the final response you're going to get from a philosopher or from social scientists. They will say, this technology should not be used because it cannot be controlled. Once they understand how difficult it is, and here's the answer. That's not possible anymore. You will use AI. That's it. You know, humanity has made a decision that you will use AI. Microsoft Copilot is already integrated in Microsoft. Yeah.
The Pandora box is open.
The Pandora box is open. And I'll tell you something else which Xi Jinping is in agreement and Donald Trump is in agreement, is that whoever controls AI, whoever develops the newest form of AI, he will run the world. So that is why we are not going to stop using AI. In terms of attack, you have drones now that they can detect various different soldiers, uniforms, tanks, cars. Very useful. AI on the diet. You build a drone, you just fire and forget. It will go there and destroy something. You know, in the war setting, that is already being advanced. Many academics and researchers are resigning once you ask them to build. I've been headhunted by multiple organizations to work on building AI for attack, and I refuse. Not only because I don't want to do that for moral and ethical reasons, I think there is no career prospect over there, and there's a very high risk that I'm gonna end up in jail. And I don't want to end up in jail. So that's why I'm not doing that for them. Even though sometimes it's the governments change, regulations change, you don't want to end up in prison. But AI is currently being used and developed for attack. And if you're not building AI for defense, how are you going to defend yourself? Imagine that you have a swarm of drones coming against, your military base, and you have no AI to shut them down instantly. You can't just take a gun and shoot them one by one. So AI is already used. AI is used in financial transactions. So whoever is using AI for stock trading will make tons of money. We already have that. Zurich has been working with high frequency trading, it's called, when you use AI to detect if a fraction of a penny, there's a difference in the fraction of a penny of a share price between the Tokyo Stock Exchange and New York Stock Exchange. If there is a small fraction of a penny difference, the algorithm would buy and execute at speed, because if you don't execute that transaction within a second, the price might change and you will lose that money, because the fluctuation is so small and changes so fast that you need to have a computer. Humans won't be able to perform that, to execute that transaction in a split second. It changes really fast. So if you're not using AI, you're not making money. What's another thing? When you're doing this kind of high frequency trading, you're stabilizing the market, because the price becomes, there's not going to be difference in the Tokyo Stock Exchange, New York Stock Exchange. You're stabilizing the market. So it's a very useful instrument, but one day it will malfunction, one day it will cause financial crash. Yes, I can tell you how I explain this in Oxford. In Oxford we have a fun fair. Every 6 months we get a fun fair. Fun fair is like when you have those big machines, you strap your child and you catapult it up in space. So you won't even be able to see your child. It becomes like this tiny little dot. It flies out higher than the highest building, and then it comes down. It's a fun fair. It goes in circles, it does this. When you walk on that street in Oxford, quite often you see the people who are strapping your child being very shady characters, quite often hungover, with headaches, unshaven. You think like you're trusting your child now to this machine and this shady character to be strapped and catapulted into space because there's some regulation. You're accepting this risk as an acceptable risk. And you're not accepting that one day there's going to be a financial crash which you can rectify and correct. Well, of course there will be. It's just money. And you shouldn't really be that panicky about using these tools. They're useful tools. They're stabilizing the market with high frequency trading. Your adversaries are already building AI, that's tools, weapons. So you have to build AI for defense. It's not a choice anymore. You're not being given that choice. Now, what is the legal aspect? Autonomy. Agentic AI makes the decision for you. AI does not make the decision for you. This is answering the question. It's actually in one of the slides. So instead of explaining it on the slides, I will explain it here. What is the biggest legal risk related to agentic AI? Can anybody tell me what is the very first AI model? The name of the model? No? Linear regression. When was linear regression developed? A year or a decade or a rough time when the very first AI model was developed? Yeah.
I think 1920s or 30s.
1905. 1905 was the linear regression. 1920s and 30s was the very first computer differential engine, which is not a digital computer. So the very first AI model linear regression was developed 20 years before the very first idea of a computer. Differential engine was not, it was a mechanical computer. And the very first computer was the digital computer was developed in 1942 by a Bulgarian professor and his assistant. And 1945 somebody else advanced that into it has a name. But that was the very first digital computer, 1942. 1902 we had the linear regression, the very first model. So we have been plugging data as researchers into linear regression for before we even had computers. Do you think that's a very dangerous model? Do you think linear regression is going to go and kill humanity? Do you think that model presents any form of risk? It doesn't. It's a calculator. Many of these AI models that we have, classification, regression, those are simple statistical models. They are not dangerous. So if you compare that with an agentic AI, which self-driving car, for example, self-driving car will in the future be very agentic. Now, think of traditional AI as a train on a train track. You know where it's going. Linear regression, classification, regression. You know what to expect. And agentic AI is going to be like an autonomous vehicle that turns lefts and rights and you just give the instructions. You don't drive the car anymore. And that autonomy is problematic. Yesterday I showed you how you can manipulate the stop signs. That's a very common example. So this self-driving car is driving in the physical world. It's no longer in the digital world. And somebody goes around and puts stickers on the stop signs on the different. So how can you control that risk? It's no longer a digital risk. It's a criminal that walks around, the child walks around with different stickers, puts them in a specific location of the sign. So the sign, for instead of being a stop sign, the machine reads it as speed up. So instead of stopping, you drive over a cliff. But that's a physical attack. It's not a digital attack at all. And I compare this with the example that I can take something, break the window, make a mess here, but they'll send me to prison. So in the same way, we're going to control those things. Problem is, if it's a digital attack and your attacker is based in North Korea, and you have no control over North Korea, you cannot go there and arrest that individual. And instead of that individual being arrested, he's actually getting promotion. Lazarus Group, which we saw yesterday, is funding the entire nuclear program in North Korea. Those guys are like celebrities. They are not penalized. Maybe if they fly here, you're going to arrest them and send them in prison forever and ever. They're never going to see the light of day. We know their faces, we know their names, we know who they are. You can't go to North Korea and arrest them. It's beyond your reach. So if you're building this kind of risks into the system, that's when it becomes problematic. But that question is answered, autonomy. Second question, how can ordinary people get access to an agentic AI? Is AI agent able to create another AI agent? This is a question about self-procreation. Artificial intelligence at this present moment is not capable of self-procreating. One of the steps that artificial intelligence needs to achieve in order to be considered alive is self-procreation. And we're actually, by the way, very close to that. So let me see the time. We have 30 minutes left, right? We have 30 minutes left. Self-procreation, it's a level when it goes beyond your control, completely beyond your control. That's when you're talking about artificial superintelligence. Because if it can self-replicate, and if it's using, let's say, a reinforcement learning algorithm, we're going to talk about in the slides about different algorithms, actually I should start with that. But supervised learning is controllable, unsupervised learning is controllable. Reinforcement learning means that it learns from the environment, it learns from this interaction. So if I start asking you guys a question, and by the end here, I think it was a game called The Broken Phone or something. By the time I hear the result here, it's going to be completely different than what I said here. So imagine that this agentic AI with 1,000 agents uses reinforcement learning, which learns from the interactions with the humans, and that somehow message gets in error, and then creates reinforcement loop of hallucination, just hallucinates after hallucination after hallucination, and then it self-propagates. And then you decentralize it, you put it on a form of a blockchain that you cannot shut it down. Well, that's what was the name of the Terminator? Skynet? Skynet? Was it Skynet? Skynet. That's a recipe for building Skynet.
Well, that doesn't sound impossible.
Doesn't sound impossible at all. Actually, there are blockchain AI agents already. It's just that the blockchain technology is not designed for AI. Blockchain technology is
But
designed.
that doesn't mean that it can't be used in those purposes, right?
It can, but to store AI model on a blockchain, it would require that the blockchain has memory. It needs to be virtual machine. Ethereum is a virtual machine. There are some efforts. Hold on, let me add. Actually, there are people who work on that. Not that one, but it hasn't really gone far. I'll show you what it needs to have. NewNet, as you can see, the share price of this promising technology, it's only red and going in decline. NewNet was a decentralized cloud. I'm not saying go and invest in NewNet. I'm definitely not saying that. As you can see, it's not doing very well. But you can have decentralized cloud. And how is that cloud based? Every spare memory that you have on all your computers that you don't use when you're connected, you sell it to NewNet, and NewNet creates a cloud. So it's based on the memory from all the users. And then they created a coin, and they wanted to sell the coin, and the coin is going down. The technology is sound, just the coin. It's not something that they didn't really build a market plan around that coin very well. And since many people don't believe in it, and since this is very difficult to regulate, European Union has a legal responsibility if you're an entity in the European Union that you keep the data within European Union. That's a GDPR. NewNet contradicts that. Because your data could be stored in a computer in Turkmenistan, Kazakhstan, you don't know wherever there is a spare capacity. So that is not going to work. There is a way how to do it. It's not as fast as cloud computing. It's not as cheap as cloud computing. It's not as easy to regulate as cloud computing. Is it going to succeed? No, it won't, because of those reasons. But does it exist? It's important to tell you, it does
Is
exist.
there an example? That's what I was going to ask you. Is there an example of this?
NewNet.
No, like something that is functional right now.
NewNet is functional. You can go on their webpage.
Okay.
Decentralized computing. This is an actual project. What I showed you was on Coinbase, the share value, how it declines, but this actually exists. You can, this works today. It's not the only one. It's not the only one. Actually, when it gets to NewNet, this is based on,
This is like P2P, right?
P2P, yes,
Yeah,
P2P.
just for the storage, not just the file exchange, but like really P2P, like from the late 90s.
Exactly. So, I currently work in Oxford Department of Computer Science. Before that, I was in Oxford Engineering Science. Before that, I was in a center called Oxford E-Research Center. And a very interesting professor called Dave DeRuhr was the director of that center, and he developed the IT network, the cables, in a very similar way like this. So when you're not using the capacity of one, then that spare capacity goes to a different office. And the way that he connected the cables after when he left the director position, went to be a director of the Bodleian Library, IT people came in and they couldn't make heads and tails out of that. They couldn't, so I was like, I can help you, but I'm leaving to the other department, and this is going to be a full-time job for me to explain how the cables are connected, so good luck. And I think what they did is they took all the cables out. They couldn't figure it out. They couldn't. They said, we don't know how to deal with this. So they took all the cables out. They demolished the building, the walls, took the cables, put a new cable. So this kind of connectivity requires somebody who knows, and then you need to keep that person to maintain it. If one individual leaves, nobody knows how to maintain it. It's very, very, very technical. Cloud computing is not that difficult. There's loads of people who know how to work with cloud computing. It's an essentialized data repository. You have engineers, you have many people applying for those jobs. It's a course that we teach in the university. This kind of thing, you need to have a very unique skill set to build that. So that's the answer to the question. Let's go back to the other questions if there's more questions here. How do you see Agentic AI in a fully decentralized protocol in terms of liability? Currently, it's, Agentic AI is only used for high frequency trading when people are lazy to do trading and they set up parameters to an agent and they say, I'll give you £1,000, make me $1 million. And how do you set the parameters? So we said it's very easy to set up an agent if you can feed specific instructions. Financial instructions are very clear. Net present value is a formula, time value of money is a formula. The trading formulas, how the market drops and there's like a lines of, that's very, very easy to feed into an AI agent. Problem is that everybody knows exactly the same thing and everybody's expecting it. So when a share price drops below a certain level, people are buying or people are selling. If you have so many people playing on that, there's a comparison. They said it's a monkey can win more money on the stock market than the most advanced trader because there's so many people trying to outsmart each other. So it's a guessing game. So if a monkey takes a rock and tries to hit it has more chances of winning than you. So can you build decentralized apps based on that same knowledge that everybody else has? No, you can't. Are Agentic AI and XAI incompatible? X-explainable AI. Is Agentic AI explainable? We can make AI explainable, Agentic AI explainable. We just don't have that yet because it's an infant industry. Now imagine the European Union is subsidizing common agricultural policy. Let's see how many people are awake. I stand up to see how many people are sleeping, how many people are awake. And if you're sleeping, you're fine. I mean, you can sleep, I don't care, as long as you're quiet. European Union funds the common agricultural policy. Very controversial, common agricultural policy. One of the reasons why UK wanted to leave the European Union, common agricultural policy. It's a very controversial funding system. You pay farmers money to produce farming product. Instead of paying them fair price, you pay them subsidies to work. That works for farmers that they have big farms and loads of tractors and employ loads of people because they have loads of product and they get percentage for each product. Small farmer prefers to get a fair price. So I work this plot of land and I earn X amount of money. I want you to pay me for my work. I want a fair price. I don't want to beg for subsidies or something. But common agricultural policy has been in existence for a very long time. The original percentage of the European Union budget was around 87%, because that's how the budget was set up. France had lots of farmers, they wanted to promote that. Now it's dropped to something like 30%, but then you have the Rural Development Fund, which are also connected, and the rural development. Anyways, why is problem to fund farmers? It's a zombie industry. In rich countries, people want to have higher salaries. In Warsaw, for example, you get £1,500 now, a salary. That was not the case before. Before, maybe it was like £300. Where I originally from, the salary is still £300. It's here in Europe, not very far. Once you join the European, and there's loads of farmers and they're not happy, they want to make more money. Now, zombie industry means that you're supporting something that it has no prosperity or growth. It's a zombie industry, it's a dead industry. Car manufacturing, that's another zombie industry. China can produce cars much cheaper, much faster. So why are we subsidizing those industries? In a capitalistic system, you need to let industries die. Because they're no longer profitable, you buy that product from another country, you create a kind of like a customs union or a trade agreement, you buy them from them because they can produce it cheaper. That's the very basics of economics. Adam Smith, the father of economics, created competitive, how's it called? Theory of competitiveness or comparative competitiveness policy, which is saying if your country has more potential to work with AI, you should work with AI. And if a country B, let's say a country that has loads of water, loads of rural land, Ukraine for example, they can produce farming product much cheaper, you should work with them because there are countries in Europe, Spain for example, and there's no water. So how can you be agricultural? Artificial intelligence is an infant industry. You're allowed to fund industries when they're in their infant stage. Means Google, for example, is too big. You cannot fight with Google. So European Union should be subsidizing infant industries to enable them to compete with those big players, because it's a new industry, it's an infant, it's a baby. It doesn't have the power to fight the big ones. So you need to support it until it grows and let it compete. But that's not what most countries do. They support zombie industries. China, on the other hand, has been taking a different approach. China has been pumping a lot of money in AI. And now China is dominating, competing with the US in terms of AI. Fair, it's fair. That's where they put the money. That is the kind of technology that they're getting. If we want to compete, we need to now up the game and even pay more money into small startups that they're trying to build AI tools. We're not going to do that. So that leads to only a path of decline, that we're not going to be leading artificial intelligence. So more questions. Is it worth to learn and certify ISO 42001 auditor? That was one of the examples that we used yesterday. Oh, I started with GitHub Copilot and I didn't really get there. So this is one of the standards. Is it worth it? It's a compliance. It's a compliance standard, and it's not really. Hold on, where is it? Where is my 42001? This will be 42002. That's work in progress. So they have many ISO compliance standards. Some are for management, some are for, yes, it's definitely worth it if you work for a big organization. If your organization requires you to do that, it's worth that you do it. If your organization does not require you to do that, going back to the conversation about Oxford not being compliant with ISO 27001, most universities not being compliant, is it worth me forcing them? Do I have the power to force Oxford to do anything? No, I don't. They make that decision. So if your boss comes and tells you, use ISO 42001, they will provide you, that will cost money, like 200-300 francs. They will provide you with the report, you read the report, you learn how to do it, you apply it. If your organization does not require you to do that, why would you do it? Do you think your institution would listen to you? They won't. Many define high performance AI by training compute. AI high performance on this. Yeah, well, actually, you have to. When you're training AI as a new model, remember these models that I showed you, they are pre-trained. If you want to train your new model, you need to have high performance computer. Usually you buy that as a cloud service. So you pay per minute of usage. Are any companies required to disclose their training compute in practice? Well, that's what the European Union AI Act will do. Companies will be required to disclose their training compute in practice. They will be required to disclose the data that they use. They will have to make the models completely transparent, so you will be able to see how the model makes the decision. Is artificial superintelligence possible? It might take. It's not only possible, it's inevitable. Artificial superintelligence is inevitable. I don't know if we're going to have time that I'm going to show you the capabilities, but AI has already surpassed human level capabilities in many sectors, and it's kind of going in a flat upward curve. It's taking over most of it. Well, probably we won't have time, so let me show you that now, because I was going to show you yesterday. This is the singularity thing that I was showing you yesterday. So is artificial superintelligence possible? That's singularity. Singularity event refers to a point in time where AI has taken over all the human capabilities, and AI is also capable of self-replicating. So it doesn't need us anymore because it can self-replicate. So this is the path of the singularity, and this is the progress. This is open source information. This is the screenshot that I'm using, just to say this is the human level capabilities, and that's AI. It has already taken over, and look what's happening with those ones here. They're going in a flat upward curve. Now, if you want to play with this, test scores, you need to go to our world in data, and you will find this. So here, you would check individuals' capabilities. So complex reasoning, handwriting recognition, image recognition, language understanding. So you can click on all of those, and it will give you the capability of artificial intelligence versus human level intelligence. This is all the way up to 2023. That is not really the current form. Now it's 2026. Now, if you want to learn more about the current level, Stanford publishes this report. Here, as you can see, it's 457 pages, 500 pages. This is from 2025. It's already obsolete. Next year, this year, they will have another 500 pages. Really useful report, but it takes a lot of reading. Now, on this here international scientific report, you would find comparisons based on benchmarks, not on capabilities. Benchmarks is when you group things together. And here, for example, we have mathematical reasoning here. That as one benchmark, there's multiple different benchmarks. MNIST is a different benchmark. The same problem persists. The black line is the human level capabilities. Those dots that they're exceeding shows that AI has already exceeded human level capabilities in maths and various different benchmarks. And the ones that they remain, they're going only in a flat upward curve. So this is from 2020 to 2024. In 4 years, AI has been able to advance so fast that now it has already gone past this black line. Now in the more advanced report. This is a more recent report from Meta. And you can click here and you're gonna find that. So this is Cloud Opus 4.5. I don't know if you guys have done any coding. Since we are 18, we have like 12 minutes left on this course. I have to show you the coding which VS Code, with VS Code. And by the way, I did mention, so here before I go into the VS Code, I did mention that you need to look for GitHub Copilot for Education. This is something that you get for free. It will cost you £10 per month if you're not a student. GitHub Copilot Education. This is how I find it. Go to Google, GitHub Copilot Education. It's going to be this link here. Getting free access to GitHub Copilot Pro as a student. Once you click on that link here, you can apply for GitHub Education as a student or as a teacher. It will only ask you to scan your ID card, your student ID card. That's all that it's going to ask. And then it's going to give you a free access to VS Code here. Look at how many different agents I have. And Cloud Haiku 4.5, Cloud Opus 4.5. These models here, if you haven't played with them yet, if you're coding, if you're developing, and if you have only used GPT-4, if that is the last thing that you use, because earlier in 2025, that was the lead model, GPT-4, then it was GPT 4.0. If you have only used that, and if you have never used 5, or you have never used Cloud Opus 4.5 or the one after, don't say that AI doesn't know how to code. Don't say that, because you haven't tested it yet. GPT-4, completely useless. It couldn't do anything for me in terms of coding. Cloud Haiku 4.5 writes better code than most of my PhD students. Now, the PhD students that I know in Oxford, 99% of the good ones are Chinese. So it doesn't actually write better than the Chinese that they're, but they're special. They only want to write code. They don't want to do anything else. They don't want to teach. They're very focused on what they're there to learn. Oxford Computer Science is number 1. Well, it used to, now this year it dropped to Imperial is number 1 in the UK. So they send their best and brightest to learn from the best and brightest, and they don't want to stay in the UK anymore. There's no jobs for them in the UK. There's more opportunities in China than there are in the UK. Now, only those students, like the best that there is being sent on national stipends from China, sent there to learn, only those can work better code than Haiku. Most of the other students that they are not full-time developers, they don't write as good code as Haiku. So if you have never used it, don't say that it's not good. You're wrong. You're mistaken. So that you get this for free. You don't have to pay anything for this. It costs like 10-20 pounds per month. As a student, you can get it for free. You can apply today in 72 hours, you will get the license, and all of this will show up into your inbox. Now, if you don't have the GitHub Copilot, you will have 2 or 3, the GPT-4 or GPT 4.0, the free ones. But as a student, when you get the subscription, you're gonna get the most advanced for free. You're not gonna pay for these agents. Those are agents. So how do you interact with them? You say a prompt. Build me an app for yada yada yada. It will build an app for you in yada yada yada. How good the app is going to be depends on what agent are you going to use and what your prompting capabilities are. Until this year, until the last year, 2025, the only thing that students were developing is prompting. Now it's changing. Just prompting is not enough. You need to be able to play with the agent a little bit more. Going back to the skills here on Method. So this is a very recent, so 5.1 codex. Remember the one that I showed you here, that's all the way up to 2023. ChatGPT came out in 2023. ChatGPT was not very good in 2023. That was version 3. Now we have 5.1, and you see how that curve is going up in terms of training adversaries and task discretion. Now, this software engineering tasks that software can perform 50% of the task of a software engineer. It's not good enough. Most people would say, I need 100%, I don't need 50%. That will double every 6 months. Did you see what happened between Cloud Opus and Code 5.1? Do you guys remember when it was 5.1? We're at 5.2 now. 5.1 was very recently. It was like a few months ago it was 5.1. Look at Cloud Opus, where is it? This will double every 6 months. All the capabilities that AI has every 6 months will double. Maybe it's not going to last forever, maybe it's going to last for 5-10 years and then it's going to peak and slow down, but you still have 5-10 years of this doubling in capabilities. In 5 years time, let's say you're doing computer science degree and you're a software engineer. Actually, yesterday, not the day before yesterday, or when it was a Friday, I had a job interview with another university for better pay, better job, and they asked me to do a coding test. The coding test was so simple that I found it laughable. And actually, at the end, I wanted to send them an email that they need to send me an apology. After 20 years of working in coding, they're giving me that coding test. I mean, the coding test was so dumb, so simple, that for me it was insult to work on that. Obviously, I passed it and I went to the interview, but at the end, I wanted to send them an email to say, you either make this coding test more challenging, or you send me an apology that you insulted me that I need to pass this coding test. Cloud Opus would pass that coding test with a flying colors. Not even really a challenge. It's going to take them 1 second. So if you give that instruction, the entire instruction that they gave me to Cloud Opus, it will pass the test in 1 second. It's not going to take 1 hour of thinking. You're not going to do prompting and stuff. 1 second, done. That is the level that we teach in the University of Computer Science. So when a student joins a course, computer science, and they learn about coding, that is the level. That the test is based on capabilities that we need to have in order to teach the course. That is what we teach. Opus is already way ahead of it, and it will double that capabilities every 6 months. You start the computer science degree, by the time you finish learning those basic level skills, AI is going to be doing those tasks automatically. Any admin job that is repetitive, responding to emails to students, that's gone, that's not going to exist. You need to retrain and readapt. Now, here we do have many slides which we didn't cover, but I wanted to cover this one slide. Actually, I want to cover 3 slides here very quickly. I'm going to spend like 10 seconds on each one. You have main types of machine learning: unsupervised, supervised, reinforcement, semi-supervised. We spoke about those models already. Unsupervised learning means that you feed the label to the model. You say, okay, those are apples, those are pears. There's a label, apple, pear, each product is labeled, and you say, learn what's an apple, then you show an apple, it knows this is an apple. That's a supervised learning. Unsupervised is when you feed the data from an entire market. Let's say you go to the market and you have apples and pears and bananas. Unsupervised learning, you just want to ask how many products there are of a different category. It would use a different algorithm, it would cluster them. So it would create a cluster, there's X amount of this kind of looking fruit, there's X amount of this kind of looking fruit, X amount of bananas. So that's unsupervised. When you have too much data, you don't have time to put a label on each one. It will do, that's what you need unsupervised. Reinforcement learning is, as we said, it learns from the environment. That's where most of the agentic AI is. So it interacts with you, is asking you questions, and learns from you. What was the most advanced form of symbolic learning? Elisa? Symbolic AI. Elisa was a chatbot like that that was based on symbolic AI, not on machine learning. But here we're talking about machine learning. How does a machine learning learns? Quite often they say AI is machine learning. Well, it's not. AI is not machine learning. AI is artificial intelligence. Machine learning is just one form of AI. Symbolic AI was a different form of AI. In the future, we're going to have neuro-symbolic AI, combination of neural nets and symbolic AI. How does a machine learn? Well, deep learning is part of machine learning. Most of the reinforcement, that's all machine learning. How does it learn? It has this gradient descent. So you give a specific task and it takes a number of steps. If those steps are too small, it's too expensive. If those steps are too big, it can overshoot. Like here, it's overshoot and it doesn't get to the peak. That bottom is what it's looking for. It's trying to find the bottom of a problem. But if the steps are too small, it's going to take too long. If steps are too big, it will overshoot. And this is the neural net, which I already explained with ping pong tables. Imagine that you have a ping pong player here, it hits a ball, and that is the simplest way. It needs to reach the other end, and then it needs to get a response back. That's the simplest way to explore neural nets. We only have 2 minutes left on this, so we're going now to the quiz. So let's use the quiz. I'm closing all these different sections that I have here. If we have time, we will cover them in a different session tomorrow. So the quiz, I'm making this live and we are going to the present mode. We have 2 people joining in. We have 1 minute on this only. Each question will have around 20 seconds for you to answer, so we might be very, very little behind, not more than a minute behind the schedule. I'm just waiting for you guys to join, and then I'm going to push the first question. Okay, let's see. First question, if it's showing. Here, as you can see, you have 16 seconds left to answer, and the answer will show at the end. We have 5 questions, and each question has like 20 seconds. So 5 times 20, 100 seconds. The answer to this one is just being revealed now. The answer is C, persistent goal detection, anomalous behavior. We're going to the second question. 20 seconds. Why does Agentic AI compliance legal attribution of responsibility? Five seconds left. B, action emerged from autonomous planning, not a single human command. Question 3, which OWASP machine learning risk becomes more critical? Well, actually we didn't really discuss OWASP machine learning, so here you're just gonna have to guess. OWASP, it's an institution that creates open standards. So it's not a compulsory, it's not like the European Union AI Act, it does not forces you to do anything, it's just saying if you want to secure your organization, this is how we think this could be done. It's based on industry experts, based on cybersecurity professionals. It's B, excessive agency and privilege. So that is one of the most critical agentic in the agentic AI system. Question 4, 20 seconds. What is the primary security failure mode of unbounded optimization loops? We said about reinforcement loop, hallucination loops, that just goes into the loop and it kind of loops, goes crazy. So what are the primary security failure mode of unbounded optimization loop? Escalation beyond intended authorization, so it escalates. And this is the last question. It's 20 seconds. As autonomy increases, legal accountability decreases. So as AI becomes more autonomous, is the legal accountability less? Is it true or false? You should know the answer to this one. We talked about it in length. Okay, so the answer is false. 70% of you guys, you got it right. So, that means that most of you got it. That's the end of the session. hope you're gonna remember when you go home to request the GitHub education, because then you're gonna get all this Agentic AI for you. I will see you on day 4, 27th of January at 10:45. So I'm doing the second session on day 4. If you have any questions, it might be useful for you to start thinking questions now about AI bill of material, software bill of material, cryptographic bill of material. Because the slides are there, but I don't have to use the slides. I can just